The last transformation we're going to learn about is a rotation. Now, we already talked about rotations being turned, but let's talk a little bit about the specifics. A rotation is a turn about a center of rotation. In our experiences that we're going to have in the coordinate plane, our center of rotation is always the origin, so it's always at 0, 0 we're going to be rotating. Rotations are measured in degrees for the angle of rotation. There are actually lots of degrees that we will see later on when we get to trigonometry, but for right now, there's really 4 that we would possibly have. Over here in quadrant 2, I have my pre-image, and it's the same rotation as if I had a 360-degree rotation. It would end up in the same spot. Now, when we're talking rotations, we have to be specific about if we're going clockwise, meaning in the same direction as a clock, which is typically to the right, or if we're going counterclockwise, which is to the left. Most rotations are measured in counterclockwise, so you'll notice that sometimes I refer to it 2 different ways. I'll do the best I can to refer to it in both ways. The clockwise over here is used for MSA, and the 270 is used for geometry. So from the pre-image, if I were to go counterclockwise or against the typical clock rotation, this is 90 degrees counterclockwise. It's a quarter turn, which means it changes to 1 quadrant to the left. 180 degrees, if you notice, does not have a mention of clockwise or counterclockwise. That's because it doesn't matter if I go clockwise or counterclockwise, I end up the same way. Notice the figure that's 180 degrees rotated. Notice that it's completely upside down and it's in the furthest quadrant from the original pre-image. Over here we've got 90 degrees clockwise, or a turn to the right, or 270 if I'm continuing with the counterclockwise spin. You might want to pause the video at this point to record the rules on your notes page. Notice it says at the bottom of the page that this is something that you need to memorize for Friday's quiz. Thursday night I'm not giving you any written homework, so I would strongly suggest you take the time to look over that. To find out what the rules are, unlike reflection and translate, we can't just count boxes, we can't just go by how it looks. We have to use the algebraic rule. If something is rotated 90 degrees counterclockwise, this is how I remember what the rule means. I turned the points, meaning they're in different locations, and counterclockwise means to the left, so the left point changes. 180 just means opposite. So if I look over here, the opposite means the opposite sign. For this one down here, 270 or 90 degrees clockwise, same kind of idea. I have to turn the points and the right point changes. There really is no easy way to go about it except to memorize those rules. We're going to just take a look and practice 270 and 90 with just 1 point. We will do more practice in class as we go. So I went ahead and I plotted the point, -4, -5, and it should be already on your notes page. If I rotate 70 degrees, 270 degrees, or 90 degrees clockwise, this is what happens. I turn the points, and clockwise is to the right, so the right point changes its sign. So I end up with -5, 4 as my new point. And how I can test it is if I went a quarter turn to the left, it would be in this quadrant 2 since it was originally in quadrant 3. Notice I labeled this A prime, so you might want to label that on your graph as A prime. Now if I wanted to take that same point and rotate it 90 degrees counterclockwise, so we're going to be going in a different location for that one. We want to take the points, we want to turn it, and we want to go right here. So my ordered pair for 90 degrees counterclockwise would be 5, -4. And you can see I'm going against the grain of a clock. So let's just make sure we recap. 270 or 90 degrees clockwise means I'm continuing, if you can see my mouse moving in the pattern of a clock. Counterclockwise means the opposite way. The most popular transformation you'll probably see is rotating 180 degrees. You'll see that on your quiz for sure, you'll see it on your benchmark, and you'll see it on MSA. So I went ahead and I gave you the original triangle already plotted for you. Now remember, when we rotate 180, that means that every point takes the opposite side. We don't switch the points, it just becomes the opposite sign. So -4, -3 is now +4, +3. -2, 0 is 2, 0. Remember, 0 is not positive or negative, so if it changes to the opposite, it's still 0. And the final point, -1, -3, is now +1, +3. So if I go through and I plot those points, you can do the same thing on your own so you can see that. We want to take a look at the actual picture and make sure it is what we said it was. We said that this picture would be upside down, and if I were to connect my dots, it would be an upside down triangle, and it's in the quadrant furthest away. In the description box for this video, there are some websites for more practice. Rotations is one of the few transformations you need a little bit of extra practice with. I'm also going to list the websites on Edmodo as well. I would strongly suggest you look at them tonight, or you can look at them on Thursday night.